From the top of this 45-meter drop tower, my friends from the How Ridiculous YouTube channel are about to release a watermelon.
Here we go.
In free fall for a full 3 seconds, the watermelon accelerates to over 100 kilometers per hour before smashing into the ground. The results are predictable, but this was just a control for the actual experiment. Another watermelon was sprayed with a polymer coating. We'll come back to what this is and how it works. But for now, let's see how the coated watermelon fares in the drop test.
That's insane. Oh, you're kidding me.
Instead of shattering, the watermelon bounces and remains intact. For the most part, anyway.
Is it broken inside?
Yeah.
It is.
It's definitely slushy.
Even with an axe, the How Ridiculous boys can't crack this shell.
How is it not? Ah! Oh, yes! Sure we can pull through that. Oh, look, it's actually... Oh! Look at the watermelon. It's intact. It's still a watermelon. Look at that. Oh, that's gross. That is amazing.
It is pretty amazing that the watermelon could survive an impact at over 100 kilometers per hour. Yeah. So I went to find out more about the coating, called Line-X.
It's a mess. The individual components are a mess. When it goes on as a big mess. You saw me wear a spray suit. It's a mess. But when you're done, you're really cool stuff.
Line-X is made from 2 ingredients.
A and B. Inside of each of these is multiple things.
But the main component of A is diphenylmethane 4,4-diisocyanate, or MDI for short. It's very reactive due to these groups on the end.
B is the poly. So the simplest way I could explain is it's a plasticizer.
The main component of B is alpha-2-aminomethylethyl, omega-2-aminomethylethoxy, polyoxymethyl-1,2-ethanediol. Long name for a long chain molecule. In reality, it would be many times longer than this. Now, I managed to convince Bryn to let me mix the 2 ingredients the old-fashioned way, with the stir stick.
And that's the A.
That's the A.
Wow.
I'm gonna dump A and B in here and you just mix them and see what happens.
All right.
Okay. Ready?
Yep.
All right. Go for it.
How quickly should they react?
They're reacting right now.
Whoa. Did you see that? That is crazy. And you can see there's almost like, I don't know, smoke or something coming
Well,
out there?
it's probably getting quite warm. I guess I could have got the thermometer out for you.
Whoa.
Can you feel the bottom? Tell me. You tell me.
Yeah, that's very hot. It's like the bottom of a hot... Ooh, very hot. Cup
Very
of coffee.
hot.
Yeah.
What's happening here is the molecules of A and B are reacting to form long chains. Where they join, they form a urea group, so the substance is called a polyurea. The structure of these chains is responsible for the properties of the coating. So it's hard because it's made of a tangled mess of molecular threads, but flexible because these threads can be stretched out and then snap back into place. Things you learn doing the reaction this way are that it's rapid, only taking seconds to react, and it's exothermic. A lot of heat is given off as these bonds form. But this ball of Line-X isn't really useful for much, so how do you mix A and B to form an effective coating?
Put them really high pressure, force them together in a really small space, high temperature, high pressure, just ram them into each other. That essentially mixes them, and then they come out the end of the gun. So from the time they're separate components, they mix, out the gun, hit your target, fraction of a second. This is where the magic happens. Inside here. So you pull the trigger, out comes Line-X.
We decided to Line-X a piece of paper to see how strong the coating is.
As you can see, it came out as a hot, high-pressure liquid. Okay, now...
How hot is that? It's quite warm.
It's quite warm, and because that's an exothermic reaction. It comes out at 150, but it keeps getting hotter and hotter. You can probably rip it right now.
I could rip it?
Yeah, I think so. There you go. Okay.
All right.
Those two chemicals just keep kind of looking for each other, or looking for something, so to speak, until every last molecule's found a home or given up looking, and that could take a day or more. But there's plenty of opportunities to cross-link right now. So that's what it's doing, and that's where all the heat's coming from.
Right.
So it's already dry. I'm not going to get any on me.
Yeah.
It's already cooling back down. So we've done the vast majority of curing and cross-linking.
Okay.
Yeah, we're getting there, right?
Yeah,
we're getting there.
It was harder.
It was harder. So now we'll wait till some of this heat goes away. We're probably getting a good amount of curing going on.
It is really tough to rip at this point.
It's strong stuff. Yeah,
No.
that tensile strength will get you.
That high tensile strength is the same reason the Line-X-coated watermelon bounces.
That's insane.
As it hits the ground, the contents of the watermelon are squeezed out sideways. But the tangle of polyurea molecules pull together, preventing the rind of the watermelon from deforming too much and breaking apart. So the watermelon bounces instead of smashing. This type of coating is now used in the walls of the Pentagon, preventing exterior explosions from launching shrapnel into the building, the main cause of injury from explosions. And it's used in bulletproof vests to contain bullet fragments that could cause serious injury. All of this is pretty incredible for a substance invented as a truck bedliner.
Yeah, come on down. Bring your entire vehicle. Anything but your cat. We'll Line-X it.
Massive thanks to the guys over at the How Ridiculous YouTube channel. You know, they're the ones that launched that basketball off the dam that is my most popular video, and they have been doing some incredible experiments like bowling ball versus axe. So go subscribe to their channel. Go do it right now.